Rockets explode their way into space, burning millions of dollars just to escape Earth's gravity. Fire, noise, risk, every launch is controlled chaos. But there is a quieter idea, one that doesn't fight gravity at all. An idea where reaching orbit isn't a violent event, but a steady climb into the sky. An elevator to space sounds impossible until physics says otherwise. A structure held up not by towers, but by Earth's own rotation. No fuel, no launch pad, just a cable stretching beyond the atmosphere, turning space from a destination into infrastructure. Before we go any further, if you love exploring bold ideas about space, future technology, and humanity's next giant steps, make sure you subscribe to Space Facts and turn on notifications. Here, we don't just talk about the future, we break it down, question it, and bring it into focus. For more than half a century, rockets have been our only way off this planet. They work, but at a cost. Millions of dollars burned in minutes, enormous risk packed into every launch. A method so violent that most of the energy goes into simply escaping Earth's gravity, not exploring beyond it. Every satellite, every space station module, every deep space mission begins with controlled destruction. But there is another idea, one so radical that it sounds impossible until you understand the physics behind it. An idea called the space elevator. At first glance, it sounds absurd. An elevator to space? A structure reaching tens of thousands of kilometers above Earth's surface? No towers holding it up, no pillars beneath it, just hanging there defying gravity? Yet the space elevator doesn't fight gravity at all, it uses it. The basic concept is surprisingly elegant. Imagine a cable anchored to Earth at the equator, extending straight upward into space. As Earth rotates, the outward pull, centrifugal force, keeps the cable under constant tension. At the far end of that cable sits a massive counterweight, possibly an asteroid or space station, pulling outward, while gravity pulls inward. The result is balance. Not floating, not falling, stable. Along this cable, mechanical climbers, essentially elevator cars, would slowly ascend. Powered by electricity, solar energy, or even laser beams from the ground, they would carry cargo and equipment into orbit without burning a single drop of rocket fuel. So who came up with something like this? The idea dates back to 1895, when Russian scientist Konstantin Tsiolkovsky imagined a tower inspired by the Eiffel Tower, one that could reach into space. Later, in the 20th century, scientists refined the idea, replacing towers with cables and introducing orbital physics. NASA, international space agencies, and private researchers have all studied versions of the space elevator in serious detail. This isn't fringe science, it's theoretical engineering waiting on materials. Where would such a structure exist? Not in the middle of a city, not on a mountain, almost certainly at the Earth's equator, where rotational forces are strongest. Many proposals suggest a floating ocean platform in the Pacific, allowing the anchor point to move slightly and avoid storms or debris. The elevator would rise from the sea into the sky, quiet, constant, unstoppable. And when could this actually happen? Not next year, not in the next decade, but possibly within this century. The single greatest obstacle isn't physics, it's materials. The cable must be incredibly strong, extremely light, and long enough to stretch far beyond geostationary orbit. Steel is far too heavy. Kevlar isn't strong enough. Right now, the best candidate is carbon nanotubes, material stronger than steel by orders of magnitude, yet astonishingly light. The problem is scale. We can make them, just not thousands of kilometers long yet. If that barrier falls, everything changes. Launching satellites would become routine. Space stations could be built piece by piece at a fraction of today's cost. Even space tourism could shift from luxury rockets to scheduled ascents. The economics alone are staggering. The cost of reaching orbit could drop by as much as 90%. Space would no longer be exclusive to superpowers and billion-dollar budgets. It would become infrastructure, like ports, railways, and airports once were. But challenges remain beyond materials. Space debris poses a constant threat. Weather systems, lightning, and atmospheric stress must be accounted for. Political cooperation would be essential because a space elevator wouldn't belong to one nation. It would affect the entire planet. This is why the space elevator is more than a machine. It's a test of humanity's maturity as a spacefaring species. Can we build something that demands patience instead of power, precision instead of brute force, cooperation instead of competition? The space elevator asks us a deeper question. Do we want to keep blasting our way into the future, or are we ready to rise into it? Because the day we build a space elevator is the day space stops being a distant frontier and starts becoming part of everyday human civilization. If exploring the future of space, breakthrough technology, and humanity's next giant steps excites you, make sure to subscribe to Space Facts and turn on notifications. Every video here breaks down bold ideas, real science, and the innovations shaping what comes next before they become reality.